Okay, is my screen visible?
Yes, sir.
Okay, fine. So last class we were discussing the turtle graphics part using the turtle package. So we'll continue with that and finish off a few more examples. So at the end we were discussing how to draw in multi-pointed polygon. Okay, so for example, uh, write the write this code, execute this particular code. Okay, you can copy paste it from here. I have pasted in the comments. You don't need to try it again. Type it again. Just copy it. You should have done the import statement earlier. Import turtle as t. This also you have to include in your program. Okay, did you finish copying it?
Yes, sir.
Okay. Execute the code. Okay. So after you run the code, count the number of points in the star. Can you tell me how many there are? Are you getting the
Yes,
same output?
yes, sir.
So how many points does this star have?
12.
In point 12. Okay, so we have drawn a 12 pointed star here. Okay. Uh, okay, let's rerun it. But before we rerun, okay, I will remove this height turtle. Okay, I will comment it. Okay, and add this code also. Okay, t dot speed. T dot speed and set the value to 1. T dot speed of 1. Okay. So in this, when we use the t dot speed, we can control the speed of animation. Okay, 1 is the smallest value. So this is the slowest possible animation. Okay. So let me run this again. Please look into where the turtle starts and where it ends. Okay, please refer to that position. Uh, so where did the turtle end up? Hello. With regard to the starting position, where did the turtle end up now?
At the same place of the starting
Same
position.
position. Okay. What was the starting position in coordinates?
0, 0.
0, 0. Yeah, 0, 0. Okay. So if you look here, the turtle started drawing the pointed star, the 12 pointed star from 0, 0. Okay, and then ended when again it comes back to 0, 0. Okay, so let's have a look into the code. Try understand that. So while true is an loop that runs infinitely. Okay, so we don't want it to run infinitely. Okay, instead, that's why because within this infinite loop, while true, which is always true, we have put a conditional break. Okay, this is where it will stop. T dot pause, absolute of T dot pause if it is less than 1. Okay, so if the absolute T dot pause gives me the position x and y values, uh, so the x and y values for absolute values square root of x square plus y square will be less than 1, or in other words 0, when it is at 0, 0 comma 0. Okay, so what we are doing repeatedly is we are turning right by 150 degree, and moving forward by 200 positions. So what is the internal angle of this star? Hmm? I'm pointing here. So what would be this angle? Internal angle? How much would it measure?
30
We have
degrees.
turned by 150. Yeah. So if we have turned by 150 degrees, okay, the inner angle would be 30 degrees. 180 minus 150. Okay. So now, can you relate this 30 degree to the number of points to this star? How is 30 related to the number of points in the star? How many points are there in the star?
12.
Pointed 12. Okay. How can you relate 12 and 30?
So since there's
Multiples of
12,
3.
30 degree,
Huh?
uh, in equate to 360 degree in total.
Yeah. So 12 times the 30 degree is 360. Okay. So now draw me a 9 pointed star then. Think of what changes you have to do and change this code such that instead of 12 pointed star it prints a 9 pointed star. If it is a 9 pointed star, what should be the internal angle? Compare it with the current one. If it is a 12 pointed star, the inner angle will be 30. So what would
Out
be a 9 pointed thing? Yeah,
40 degree.
40 degrees. So how much should I turn right by?
Once
T dot right what? 1? How much?
140.
Yeah, write the program. Make that change and see whether you are getting it. Getting it? No, no, not this. I think it's 160. I think for 160 you will get a 9. Excuse me. 180, 160, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So you can draw such repeated pointed stars by using this generic while loop. By changing values of right, you can try drawing different patterns. Okay, you can explore, you can change these values and find for yourself like what all different patterns it's going to draw. Okay. Keep your the system on mute when you're not discussing. Okay, come. Next thing we will look into methods color, begin fill, pen up, pen down, and go to. Go to we have already saw. Pen up also I guess we have seen earlier. Run this code. I'm pasting it. I'm sending it here. Copy the code and run. Okay, finished copying.
Yes, sir.
Tanmay, can you hear me? I think device not connected. What happened? Okay, I'll just be back in 2 minutes. Just okay. So let's run this. I have to close the previous one. Okay. So in this, we are looking at t dot color. By looking at the output, can you tell me where are this black and red being used?
Black is
Black,
used as the outline.
black
Line
as the
color,
border and red as the filling.
filling color, right? Okay, and then you should yeah, tell it to start filling by saying t dot begin fill. Okay, so after begin fill, whatever you draw in your program, if it is a closed structure, okay, then it fills the polygon or any closed structure with the color specified. The fill color is red. Okay, so t dot circle, it will draw a circle of radius 50. Okay, what we'll do is we will reduce the animation speed t dot speed to 1. Okay, so let's run the program again. So it is drawing a circle. Okay, and then we use pen up to move from one position to another position. From so it drew this first circle at 0 0. Okay, and comes back to 0 0. From 0 0 I go to 100 but I don't want to draw the line there, so I am using pen up and then go to 100 it will go to 100. We make pen down so that next time also whatever whenever it moves, it draws a line. We draw a circle and then we see that the end fill is called. Okay, so when end fill is called, okay, we are instructing that, okay, at this point, whatever is between begin fill and end fill, fill them with the color specified. Okay, so what change should I make if I want only the first circle to be colored and not the second one?
We can put end fill after a line.
um, yeah, make that change and see whether you are able to achieve that. Only the first circle should be red, other one should not be filled.
Yes, sir.
Getting it?
Yes, sir.
Okay. So by using begin fill and end fill, you can decide, okay, which portions can be colored and which not. So can you draw? So what you have to do now is to draw a square and fill it with some color. Try that on your own. Okay. So there is no built-in method to draw a square. You have to draw a square actually. Tanmay, can you tell me how you will draw a square?
So to draw a square, we can write t dot forward and
Ah,
I don't know
right.
t dot
Okay, T
forward.
dot forward. Ah, after
And then
some distance.
yeah, give a unit to that, and then
Huh.
t turn. Then we can write turn left, like
How do you
the
turn left?
t dot left.
Huh. By how much degrees?
By 90 degrees.
Okay. Then
And then Again, T, I don't know, so one
How-
second.
No, okay. Like you can imagine, right? You have moved 100.
Yeah.
It has drawn one line. You have turned left by 90 degrees. Next, what are you going to do?
Next,
You are again moving forward.
yeah, again forward.
Hmm.
Forward or like, then we again turn it
See, when you
downwards.
have turned, turn, okay. So the turtle is pointing towards the downward direction already. Okay, so you should say T dot forward only.
Yes, sir. T dot forward and
Hmm.
the
So
same unit.
repeat the rest. Repeat the
And
rest. Repeat the
yes,
rest. And try doing it.
yes, sir.
Disha, did you finish?
Just a minute, sir. I'm almost done.
Okay. Okay. Try. Both of you try it. If anyone has finished, you can share your screen and show the result. Did someone finish?
1 second, sir.
Sir, I got the square shape, but I'm not able to fill the square.
Okay. Let's see. All your instructions of drawing the square should be between T dot begin fill and T dot end fill.
Yes, sir, I did that. I'll just try again.
Huh. Share the screen. Share the screen. Let me see. T dot, what is this x plus 1? Okay, loop. Okay. See, begin fill and end fill should not be in the loop.
Oh, okay.
That you're not doing it repeatedly. You are doing it only once. It should be outside.
Okay. I'll just correct that.
Yeah, yeah. Okay, fine. Okay, Tanmay, were you able to draw the square?
Sir, my Python is like not working. It says installing something.
Show me. Show me what.
1 second, sir.
Can you share your screen? Let me see what
Yes,
error
sir.
you are getting.
1 second, sir.
Okay.
Ali and
You click on the present button and share your screen. Let's see what error you're getting. Oh, you already got it. Disha, is it working now?
Yes, sir, I got it.
Yeah, okay.
just
Tanmay,
yes, sir. Sir, when I try to present it, my screen just
ah,
reload. My screen starts reloading. One
okay,
second,
okay.
sir.
Okay. Okay, anyway, I will show it. You can verify it here itself. Okay. So T dot begin fill for I in range 4 function. You can use a for loop or a while loop, whatever. Every time turn left or turn right. It's up to you. Okay. T dot left by 90, forward by 100. So this entire for loop is placed in between begin fill and end fill and the T dot done function. Okay. So this will draw us. Okay, it will draw a rectangle as a square and then fill it with the color specified. Okay. And depending on the kind of operating system you are going to use, okay, let's see what will happen if we use this begin fill and end fill function in printing that pointed star. Okay, same code that you had earlier, you can just add begin fill and end fill before and after the while loops. Okay, you could possibly change the colors. If you could try different colors. Turn right by 150. Okay, Maybe sometimes in some cases you may get this entire thing white. Some of the inner regions are white here, but on some operating systems, okay, so it is dependent on the graphic system of the operating system, whether it reads this as a inner region or an external region. Okay, and then it fills up with the colors. They can display different such patterns like this. Okay, are you getting this kind of a similar output, or getting completely colored one?
Um, I got a similar one, sir.
Similar one. Okay, okay, fine then. Okay, let us see how we can make use of loops also to draw. Uh, which one was it? Yeah, this one. Yeah. One more feature, there is a dot method also. Okay, you can see this. T dot dot. You can type. Color is optional. Okay, you can just say T dot uh, dot. Okay, then T dot pen up. T dot go to 100 comma 100. T dot pen down. First one we will not use color. Second one we will use color. So this is how you can draw a dot, and the size of the dot is controlled by this parameter 10. Suppose I give this 30. Okay, let me rerun the program. You get a much bigger dot. Okay, and if you give the second parameter, which is color, you get a different colored dot. Okay, let me hide the turtle. T dot hide turtle. So after yeah, you see a black dot and a green dot. Okay, this is simple. How to draw a dot using the thing. Okay. Mm, okay, that's not required, right? Okay, write this code line number 134 onwards. Finished. For steps in range 100. Okay, 132 not required. What happened? Are you getting the same output?
Yes, sir.
Okay, so let's try to understand how we are able to draw this spiral-like figure. Okay, so here there are two variables, step and c. Okay, which keep changing in the program. So initially steps, what is the initial value of step?
Zero.
Well, 0. Yes, step starts with the value 0. Then in the loop, okay, what is the initial value of c? What are
Blue.
the possible values C is taking? Blue, red, and green. Okay. Steps can take values in the range 0 to 100. C can take values in the range blue, red, and green because they are specified here as a tuple. Okay. This is called a tuple. We'll learn tuple shortly. So it's a collection of elements enclosed within parentheses, round brackets. Okay. So it takes one element at a time. So first time C will take blue. So T dot color. So T dot color function will set the line color. Okay. And we have used color earlier also. Okay, where we gave it a second parameter. Okay. So that is only when we are required to do filling. Okay. So this the second will be the fill color. In this case, we are not doing any fill operation. It is only the line color. So you give only one parameter t dot color c. So first it will take it will set the turtle color to blue. Next, it will move forward by steps amount. Okay, initially, so because it is 0 for the first run, it doesn't move. Okay, then it turns right by 30 degree. After that, next what it does is, what is the where will the control go next after rotating by 30 degree? Will it go to the outer for loop or the next run of the inner for loop?
You
Look
go
at
to
the
the outer
output.
for loop.
It goes to the outer for loop, is it? See, after drawing blue, it is going to
Yeah, you
red
go to
and
the
then green.
inner.
So the inner for has not finished execution yet. Okay. So outer for also has not finished execution yet. Steps value is 0. For C in blue, Okay, it has taken one value, executed this. Next time it takes C in red. Okay, again repeats the operation. Okay, then next time it takes green and again repeats the operation. So for the very first time, because steps is 0, okay, you will only see the turtle changing color from blue, red, green. Okay, but it doesn't move from the place because steps is 0. After C becomes green, okay, so it has exhausted all the options blue, red, and green. So the for loop, inner for loop finishes its execution. It goes to the next iteration of the outer for loop. What would be the new value of steps? After 0, what is the next value it is going to take?
1.
1. Okay. So 1 steps will be now having a value 1. It enters the for loop. It now again encounters the inner for loop. So it restarts the for loop again. So it will set the color to blue. This time it will move by one step forward and then turn right by 30. Next, color is set to red. It will move by one step forward and then turn right by 30 degree. So in this time it would print a red line because color is set to be red. Next, again it sets the color to green, moves one position, steps by one, turn 30. Like that, it keeps on drawing from the inner position. It keeps on drawing outwards. So as long as and you can see that as step increases, okay, the line length drawn by t dot forward keeps on increasing, and we get a spiral, outward growing spiral here. Okay. So if you want to draw a much larger spiral, you can increase the range. You can set it to 200, then it would draw even more larger, and so on. Okay. If you want to use more colors, you can provide one more like comma, uh, what, blue, red, green, let's say some other color, yellow. Okay. So now it is using four colors. Okay, yellow may not be that prominently visible because it is light. Okay, but you can make up the difference where the yellow color is appearing. Okay, I think that's enough. Yeah. Okay. So these are some of the examples for turtle graphics. Okay. One assignment I want you to try today is to draw a chessboard. Right? Hello. Uh, you
Yes,
guys
sir.
can hear me, right? Yeah.
Yes,
Yes,
sir.
sir.
The question is, you are supposed to draw a chessboard. Okay. So how does the chessboard appear? What will be its dimension?
Square with black and white squares
That's
in
what.
it.
How many squares will be there? How many squares are there in it?
8, 8.
So you have to draw a 8 by 8. You have to draw 64 squares. Okay, you can use loops actually. Okay, you can draw a nested loop which runs. The outer loop runs 8 times. The inner loop runs 8 times. So totally it would. So each time you draw a square and decide whether you have to fill it or not. Alternatively, okay. Yeah. So in the chess board, you would see that if one square is black, the square next to it would be white, and so on. Okay. So you can use that logic. So you can use the if condition there to determine whether to fill or not. And you know how to fill a square also. That code also is being given. And then um, draw the chessboard. Okay, I will leave that as an exercise. Okay, one more thing. Okay, turtle dot. Okay, another thing, one more function in turtle graphics is the pen size. Okay, p dot fd 100 p dot uh, pen size, let's say 3 p dot fd 100. Okay, we are using a method called as pen size. So this will decide the line width. Okay, so if you are by default, the pen size will be 1. Okay, if I increase the value, you will get a much more solid line. So let's run this program. Okay, so do you observe what is the change that you observe after we use pen size?
The line is thicker.
Thicker. Okay, so if you increase the pen size further, like 5 6, you will get even much wider or thicker line. Okay, so this is the pen size function. Next, uh, as a last exercise, okay, we will see uh, an example where we will build a grid. Okay, uh, so you know grid, right? Something similar to a chessboard only. So in that grid, we will make the turtle start at the center of the grid, and the turtle every time moves in one of the directions, north, east, west, or south. Okay, randomly. That direction is chosen randomly, and it moves by 1 unit every time. Okay, so we keep on. So we will make this turtle turn randomly every time. Okay, and move by 1 unit, one position in the grid. We keep on doing this as long as the turtle stays within the grid. Whenever it goes out of the grid, we will stop the program. Okay, so first let us look at the program output. Wait, I will further reduce the speed. So this is one way of drawing the grid. First I am drawing horizontal lines. After that, we draw the vertical lines. And then we make the turtle start at the center, and it is moving randomly every time. So you can see that as long as the turtle is within the grid, okay, it is moving randomly. Okay, now see, it has reached the boundary, it stops. Okay, so this is what we are achieved to we are supposed to do, make the turtle walk randomly in a grid, let's say. Okay, so oh, let me run it again. Should I not have closed it? Okay, So first let us understand the coordinates used in this program. Draw faster. Okay. So uh, this endpoint, can you see the cursor? Can you see my cursor pointer here?
Yes, sir.
Okay, this is 80/80. Okay, x also is plus 80, y is also plus 80. Okay, so this is minus 80 plus 80. This is minus 80 minus 80. This is 80 minus 80. Okay, this is the coordinate system. So this center is 0 0. Okay, so what we did was we started from this uh, minus 80 position and started drawing horizontal lines. After finishing this, we went to uh, minus 80 plus 80 position and then started drawing vertical lines downwards. Okay, so let us try to understand that piece of code. So for generating random numbers, we have imported the random method. Okay, so this is a different kind of a import statement. Like we said earlier, we used to do import random, and then if you wanted to use the randint function, we used to write random dot randint. Okay, random function, random package not only has randint, um, not only has randint, it also has the choice method, it had the random method, and so on. So when I do import random, all those methods are imported. If I want to just import only one method from random, you can use the second syntax. From the random package, import randint. Okay, so only this function is imported, and you don't need to write it as random dot randint. In this case, you can directly use it by its name, randint. Okay, that's the difference between the import package name. So if I do import random, it will import all the methods. You can do a selective import by using the format from package name import method name. Okay, so from the random package, only import the random method. Okay, so you can set the color of the turtle to some okay, here I have not made import turtle as t. It is so that's why everywhere we are using turtle instead of t. Set the turtle color to some color of your choice. Okay, so I want the grid to be in gray color. I have set it to gray. Then x is starting from minus 80. I close the output window. J. Okay. Okay. So first line, if you see, okay, the place where I am pointing, the coordinate is minus 80 and minus 80. X is also minus 80. Y is also minus 80. So let's see how we are going to draw the line. Okay, line number 9, the value of x has been set to minus 80. So see this range function runs for, so is taking three values. So this is of this is the start value, end value, and then the step. Okay, so it is going on from minus 80 to plus 81. Okay, with 81 not included but 80 included. Okay, and it changes in the increments of 10. Now tell me, what is the first value of y?
Minus 80.
Minus 80. Okay, before this, when we started the turtle, what is its position? Initial position. What is the turtle's initial position? In any of your programs, where does the turtle start from?
Oh, 0, comma 0.
0.
Yeah, 0 0. Okay, the initial position was turtle's position was 0 0. Okay, I want to draw from minus 80 to 80. Okay, so I have to make the turtle come from the center here without drawing a line. Okay, so x is minus 80, x does not change, y keeps changing. Okay, see, this x value will remain minus 80 only, it is not changing. Only the y values are changing, so that you are, whenever I change the y, okay, it is going to draw a horizontal line at a different value of y. Okay, so turtle dot pen up, pick the pen up and then go to xy. Okay, x is minus 80, y is minus 80, it goes to minus 80 minus 80 after executing this go to. Then I have made the pen down, okay, using the pen down function. And then what will be the turtle pointing to by default? Which direction will the turtle be pointing? Left or right? When you start your program, how do you see your turtle? Is it pointing in the leftward direction or the rightward direction?
Right?
Right, right. Okay, always at the beginning, you always see a turtle pointing rightwards. Okay, so that's why I said turtle dot forward by 160. Okay, I want to build a grid from 80 80 to minus 80 80. So the size of this will be 160. Okay, so minus 80 to plus 80 will be 160. That's why I say turtle dot forward of 160. So the turtle will draw this line first. Okay, after that, one run of this loop is over, it comes again to the next one. What will be the new value of y? What is the second value of
Minus
y? First value
79.
was minus 80, minus 79. Why? Because from minus 80 we are going towards 80 plus 80. But the steps is not 1. It is not minus 79. The step factor is 10.
Oh,
Okay,
sorry, minus 70.
minus 80 plus this step factor. Okay, by default the step factor will be 1, but here we have said that the step factor will be 10. So how much is minus 80 plus 7 plus 10? If I add
Minus
10 to
70.
minus 80, minus 70. Okay, so does the x value change? No, x value doesn't change, y value change, because y is changing in the range, x is stagnant. So we get x to be minus 80 and y to be minus 70. So from this position, what we are doing? We are doing a pen up, okay, and then we go to the position xy, which is minus 80 minus 70. The turtle comes here. We do a pen down, and then again we move forward by 160. It will draw the next line. Next, add 10 to y, so it becomes minus 80 minus 60. It draws a line. Like that, you keep on adding values to y. Okay, at some point y becomes plus 80. Plus 80 is still within the range, it is lesser than 80 plus 1. So it will draw this horizontal line also. Okay, afterwards, when y is incremented, it stops. Okay, at which point x is having a value minus 80. Okay, and y will have a value of plus 80. Okay, so only the horizontal lines have been drawn using this for loop. Did you understand this particular part? How to draw repeated horizontal lines?
Yes, sir.
Okay, see this particular part. Every time we are increasing y by 10 and making it move forward by 160 position. So it is drawing the horizontal lines. Okay, till where? Till y becomes 80. Okay, at this point y became 80. It comes out of the for loop, and now next we set y to positive 80, and we make the turtle turn right by 90 degrees. Turtle was pointing to the eastward direction. When I make the turtle turn right by 90 degrees, which direction is it pointing in? From east you turn right by 90 degrees. Which direction do you get? Tanmay,
Sir.
you are facing east direction. You turn by 90 degree. Which direction are you facing?
West. No, no,
If
no,
I
no, no,
turn
no,
by
no, no,
90
no, no,
degree, will
north,
you
north.
point west?
No,
Huh?
north, north,
Turn
north.
right side.
Yeah, no.
You are
One
pointing
second.
eastwards.
North.
Disha,
Sir, it'll be south.
it will be south. Okay, see, you are pointing towards the eastern direction. North is to the left, and south is to the right of you. Okay, so if I turn right by 90 degrees, you would be pointing to the south direction. Okay, observe carefully when I run the program again. See, now it is pointing in the east direction. Okay, the turtle is pointing in the east direction. Okay, to draw lines downwards, I should make it point to the south direction. See, after this, see, when I turn right, the turtle is now pointing downwards. Okay, did you understand the turtle dot right 90 part,
Yes, sir.
Tanmay?
Yes, sir.
Okay, so it is pointing south now. Initial value of y is 80, and what is the initial value of x here in the loop? Where is it starting from? What is the start value of x?
Here.
Minus 80.
Minus 80. Okay, we are so range function. There are three parameters. First parameter is the start value. Second parameter is the stop value. Third parameter is the step value. Okay, so first time when this for loop runs, the value of x is minus 80. Okay, and the value of y is plus 80. So which would be the position there? X is minus 80, y is plus 80. Okay, this is my 0 0. So this position is the value of x and y. Okay, we make a pen up and tell the turtle to go to this position xy. So turtle comes to this corner. Okay, and it is pointing downwards. So from here, if I say turtle dot forward, it will draw a vertical line, okay, downwards by 160 positions. Next time, in the what will be the next value of x? In the next iteration, what is the next value of x? Tanmay, after minus 80, what is the next value?
80.
It will directly go to 80. 80 is the stop value. What does this third value mean? What does 10 mean?
So 10 is the.
Interval size. Change in intervals of 10.
Yes, sir.
Okay, so minus 80. If I add 10, will it be 80?
No.
What will it be? Minus 80 plus 10 is how much?
Minus 70.
minus 70. So that would be here. Can you see my cursor?
Yes, sir.
Okay. So x will be minus 70, y will be 80. It will draw again. Okay, we make the turtle go here by using pen up and go to, and then when we do pen down and do forward by 160, it will draw the second line. Okay. Now again x is reduced further, x will be minus 60, y will be 80, which will be this position. Okay, yeah, using go to and pen up, we will come here again, draw a line, vertical line, like that. X changes from minus 80, minus 70, minus 60 and so on. It will come to 0, 10, 20. At a point it will become 80 also. It will draw the line. After that, if I add 10 to it, it will be 90, which goes beyond the range. It is not in the range minus 80 to 81. So the for loop will stop. So after the second for loop, okay, what part of the program is finished? Disha?
Yes, sir.
After the second
Um,
for loop, how much amount of task we have finished in the program?
so we still have to do the random movement part.
No. I am asking what is done till that point. Till say we have finished executing this 22 lines. So what would the program have done by now?
The program, we would have finished forming a grid.
Grid. Okay. So this code, okay, so this part draws the horizontal lines. This part draws the vertical lines. So after doing that, we would have finished drawing the grid. Okay. Next, we want to come to make the turtle move randomly, and to make it visible. What we are doing is, from now on we will draw a much thicker line. How do we increase the line thickness? By using the pen size function. And also we want to change the color of the turtle so that it is easily visible. I set the turtle color to red. Okay. And we want this turtle to start its journey from the origin 0 0. So we move the turtle to move to the center of the grid by using pen up, and then say go to 0 0 0 0 and pen down. So after this particular code, what would have happened is, we would have initialized a turtle at the center of the grid, whose line size will be 3 and color will be red. Okay. So here at the center, what will be the position of what will be the values of x and y?
Um, 0 and 0.
0 0. Okay. So we set those values of x and y to 0, and we will make the turtle move randomly, subject to the condition that as long as the absolute value is less than 80. Okay, so in this grid, what is the possible positions? Tell me, what is the coordinate of this corner? I'm pointing my cursor here. What is the
Minus 80
value of
plus
x and minus 80,
80.
comma y will be plus 80.
80.
80.
Okay, minus 80 80. This will be this corner,
Plus 80 and plus 80.
plus 80 and plus 80. This will be, x will be
Plus 80 and y will be minus 80.
minus 80. This will be, both of them will be minus 80. Okay. So the turtle positions can be in the range minus 80 to plus 80, either in the x direction or in the y direction. Okay. So you can say, if x is less than 80 and x is greater than minus 80, you can write the condition that way, or we can simplify it further. Okay, if I perform an absolute of x, it has to be lesser than 80. Do you agree with that? Did you understand why x absolute of x is less than 80? it is same as saying x is in between minus 80 and plus 80. Okay. Hello.
Yes, sir.
Hello. Did you get this?
Yes, sir.
Yes, sir.
Okay. Yeah. Absolute function on a single value will convert it into a positive value. Okay. If it is already a positive value, it will leave it as such. If it is a negative value, it will convert it into a positive value. So my x and y values are going to be changed in the program. Okay, see, I am adding 10 or subtracting 10. Okay, all these things later we will see. So at any point, if x is less than 80, continue, and also both conditions should satisfy. Okay, so as long as the turtle is within the grid, when will it be within the grid? When both x and y are lesser than 80. Whenever they become equal to 80 or greater, okay, we stop. So now, how many possible directions will the turtle move in?
4.
Which are they? Obvious, right? Which are those
North,
4 directions? Huh?
north,
Northeast,
south, east, and
southwest.
west.
Northeast, south, and west. Okay, but uh, every time it moves one step ahead, it turns in a random direction. Okay, I want it to turn randomly. Maybe one time it will turn east, another time it will turn northwards, another time it will turn maybe south or something like that. So because there are 4 possibilities, okay, so I will say that I will generate a random number in the range 0, comma 3. What are the possible numbers that could be generated in this range? R is equal to randint 0, comma 3. So what numbers might you get here?
Zero, 1, and 2.
Is it? Think of it. Randint and range are not the same. If it
Oh,
is range
sorry.
of 0, comma 3, 3 is not included. But randint, it includes 3.
Yes, sir.
Okay. So it gives you any number which could be either 0, 1, 2, or 3. So which means that there are 4 possible cases. Okay. So I make a assumption like if the random number generated is 0, I would make the turtle walk eastwards. Okay. So why eastwards? I have just chosen. Okay, you can make it walk southwards also. It's up to you. So if it is 0, I make it walk eastwards. If it is 1, I make it walk southwards. If it is 2, I make it walk westwards. And 3, I make it walk northwards. That's why I have 4 different cases. If r is equal to 0, if r is equal to 1, r is equal to 2, r is equal to 3, and so on. Okay. One new function that we have used here is turtle dot set heading. Okay, let's see what this turtle dot set heading does. Let's close our program. Um, okay. Hey, what happened to this? Currently, which direction is the turtle pointing to?
Towards the right side.
Right.
Right. Or in terms of directions?
East.
East.
East. Okay. So set heading 0 makes the turtle point eastward. Okay, I just ran an instruction here. Turtle dot set heading 0. Okay. Let's see what happens if I do turtle dot set heading 270. Okay, just turtle dot set heading 270. What do you observe now? Which direction is it pointing to?
South.
Is it south? Okay. So you have to remember, if I use set heading 0, it points eastward. If I make it turtle dot set heading 270, it points southwards. If I make it 90, what would it possibly point to? Turtle dot set heading 90 points in which direction?
North.
North. Okay. And if I want to make it point westward, what should I give? What command should I give? Hmm? Hello?
90 again.
No.
270.
See, why should I use set heading then? I can use right, no? Turtle dot right will turn it from the current position, relatively it will turn. Okay? Set heading 0 always will make it point eastwards. Set heading 90 will always make it point northwards. Set heading 270 will make it point southwards. So what should I do to make it point
80.
westward? Huh?
180.
Turtle dot set heading 180. Okay. So if we run this 180 and see, it is pointing to the westward direction. Okay. See, turtle dot right and left are relative. They turn the turtle with regard to the current position. Okay. Like for example, if I do here, turtle dot right of 90. Okay. So look, the turtle is pointing westwards. From here, I am making it turn right by 90 degree. Okay, press enter. So relative to the previous position, it turned it right. Okay, so left and right are relative to the previous positions, whereas set heading is absolute. Okay, so if I now run turtle dot set heading 0, okay, so it doesn't matter as to what its previous position was. Set heading 0 will make it point to east. Set heading 270 to south. 90 to north, 180 to west. Okay, did you understand the set heading methods now?
Yes, sir.
Hello?
Yes, sir.
Okay. Okay. So now we will use that in our programs. So initially my turtle was at the center. Okay, we have made the turtle, red color turtle, to be positioned at 0, 0. Okay, and then we have calculated the values of x and y. Okay. Next, we generate a random integer. Okay, so we are actually, this is generating a direction. Okay, if it is 0, it is east. Okay, if it is 1, it is south, and something like that. Okay, 2, it is west. 3, it is north. So if we have to move eastwards, okay, so x value is going to change, and x value will change in the increasing direction. Okay, so every time I move by 10 positions, because my grid, each grid is of 10 units size. Okay, so if I want to move by one grid, I have to increase x by 10 units. Okay, increase or decrease by 10 units. So because I am walking towards the east direction, so if I am moving in the east direction, the y coordinate will remain the same, but x is going to increase. Okay, so increase x by 10 and then make the turtle point to the east direction, and then say turtle dot forward of 10. So from the current position, it moved uh, 10 steps in the eastward direction. Okay, if r is 1, then I have to walk southwards. So when I walk southwards, what happens to the y coordinate? Does it increase or decrease? Hello?
It decreases.
It decreases, right? That's why I am decreasing y by an amount 10. Okay. Make the turtle point southwards, and once it is pointing southwards, move it by 10 positions. Same way, if the random number generated was 2, I have to move westwards. So when I am moving westwards, which coordinate is going to change?
X coordinate.
X coordinate is going to change, y remains the same. X is going to increase or decrease if I move westwards?
Decrease.
Decrease.
Decrease. That's why we decrease x by the amount 10, which is the size of our grid. Okay, same way, set heading and set forwards. And if I am walking northwards, x remains the same, but y increases. So we have done that. Okay, so this thing keeps on repeating. Okay, it keeps on generating these directions, one of the directions, and move accordingly, as long as either x as long as both x and y are lesser than 80. Okay, so this loop we have used, and so both x and y should be less than 80. Only then it will execute this body of the while loop. Okay, so even if one condition fails, suppose say okay, in our case, let's run the program. Okay, I have to do turtle.done here. Okay, see, if you don't use turtle.done as the last statement, your turtle environment will not close. Okay, so let's run the program again. Oh, 1 minute. Let me remove this delay. Let it do faster. Okay, so in this case, in our while loop, which condition failed? Can someone tell me? Look at the last position of the turtle and tell me which condition failed, whether the first condition in while failed or the second one failed. Hmm?
The second one.
What is the value of y then in that case?
Y is 80.
Y is 80. Absolute of 80 is also 80. Okay, so 80 will not be less than 80. So how does the AND work? AND will be true only when both the conditions are true. Okay, in all the previous cases, x and y were lesser than 80. They were within the grid. That's why it was continuing. Once it hits the boundary, it stops. Okay, so the second condition failed, and then the loop terminates. Suppose say randomly, let's assume that the turtle was moving randomly and it came to this position. Okay, can you see my cursor here?
Yes, sir.
Okay,
Yes,
so
sir.
in this case, which condition, what is the value of x?
Minus 80.
Minus 80. Absolute of minus 80?
80.
80. Okay, so 80 will less than 80 condition will fail. Okay, so if it reaches this boundary also, the program will stop. If it reaches the bottom boundary, okay, what will be the value of y? Let's say at this position. Tanmay, what is the value
Minus
of y? minus 80. Okay, absolute of minus 80 is 80. 80 less than 80 will fail again, so it stops. That way, same way you can reason, if it hits this boundary also, x value will be equal to 80. Absolute of 80 is 80. 80 is not less than 80, it stops. Okay, did you understand this random walk program now? Any doubts in the program?
No, sir.
No? Okay. I will share this program. You can run it later. Okay, after the class is over, you can again look into the program and see. Okay. So this is how you can make use of the turtle to render graphics onto your uh, window. Okay, so we also learned how to use repeated structures in turtle, like you can use conditions, you can use repeated structures like while. Okay, earlier we saw where we can use for, all such things. Okay, so with this we finish the discussion on the control structures. So let me give a quick recap. There are three types of control structures. Okay, one is the decisional or branching control structures. Second one is the repetition or the loop control structures. The third one is the jump control structures. Okay. So, Tanmay, can you tell me which control structure we studied under branching or decision making?
If,
If,
else,
okay, if else,
and
and the
else.
if else if.
Yeah.
Elif, if else, elif. Okay, those three. Okay, these are which are the repetition control structures that we studied?
For and while.
For and while. Okay, Tanmay, can you give me an example of a jump control statement?
Um, so jump
Yesterday,
control.
last section we learned. If you want to forcibly terminate a loop, what will you use? Which control
Break
statement you
and
will use?
continue.
Break. No, no. Forcible termination. Which one will you use?
Break.
Break. Only break. Okay. If you want to skip a part of a loop and go to the next iteration, you will use continue. Okay, so these are the control structures provided by Python, and we looked into sufficient examples on all of them. Okay, so after learning these control structures, the next topic that we are going to look is functions. Okay, uh, okay. So before we look into functions, let us take a scenario. Okay, uh, let's assume that you start a shop. Okay, assume that you start a shop, you're alone. So initially when you are maintaining that shop, you yourself are doing all the task. Okay, so you are handling customers, at the same time you are also making purchases to bring items to your shop. Okay, at the end of the day, you might be doing some accounting, you might be writing down what are the expenses, all these things. Okay, uh, later you see that you are doing good business. Okay, you are getting too many customers. So what would you do then? At that point, will you still continue doing this task alone?
No, I
No.
would acquire some help.
You would require some help. So for help, what would you do?
Employ
If you
someone.
were running a shop, you will hire someone else, right? Okay, let's say you will hire three more people, or say two more people. Okay, what would you do with those two people?
I would give them a specific task to perform or do.
Like you may say, okay, one of you will do the purchasing and bookkeeping. Okay, another person will handle the customers, something like that. Okay, you can still say that, okay, you can both of you can do the purchases, both of you can handle customers and something like that, but that would create confusion. Okay, as like well, let's say you your business grows further, then what you will do, you will have departments. Okay, you will have a purchase department, you will have a customer handling department, you will have a separate billing department, something like that. Okay, so when the things that you are trying to do become complex, okay, become larger in scale, what you try to do is you try to break it into smaller chunks, smaller units. Okay, and say that a particular unit performs a well-defined function, okay, well-defined task. Like the sales department is in charge of only doing the sales operation. Okay, they will not be worried about how to give the salary at all. Okay, that is not the job of the sales department. That would be the job of the HR department. Okay, like that. So in programs also it is the same. Like if you have a very large task at hand, you can break that large task into smaller subtasks and make the subtask be done by a single entity. Okay, and another thing is, let's look at this program. Okay, looking at this program, what are we trying to do here? Highlighted code, you can see the code, right?
Yes,
Yes,
sir.
sir.
Yeah. So have a look at the code and see what we are trying to achieve here. Can you tell me what this program is doing? That highlighted part,
We're printing a sum from the range given.
which range?
First one is 1 to 11, the second one is 20 to 38, the
30
third is,
and so on, right? Okay.
yeah,
So we are printing the values in a we are printing the sum of values in a specified range. Okay, 1 to 11, 20 to 38, 35 to 50. Okay, so here there are three different ranges. Okay, except for the start and end values of the range, the look at how we compute the sum. Okay, do we compute the sum in any different manner each time?
no,
No, right? Every time we start with assuming that sum is 0, we take the first value in the range, add it to sum, add it to sum. We take the second value in the range, add it to sum. Like that, we repeatedly keep on adding. Okay. So here I am rewriting the same code again and again. The only difference is in the range values. Okay, so this is pretty much common when we are trying to solve programming problems, that a particular computation will be done repeatedly at different places. Okay, a single task is being repeated. So it doesn't make sense to write the code again and again. Okay, and I can't use a loop also here because the range values are changing haphazardly. Okay, so if I use a loop, okay, there should be a proper say a connection between successive executions. Okay, there will be a particular way in a linear manner, it keeps changing. Okay, but here the range is changing randomly, so I can't say that I can use a loop and solve this. Okay, so in such cases, I have to rewrite the code again and again and again. Okay. Maybe sometimes when I am typing, it is quite common that I may make a mistake and type something else. Okay. Like instead of doing addition, I accidentally typed minus and I get a wrong result. Okay. So to avoid this, what we can do is we can write what is called as a function. Okay, so a function in a Python in Python is a element that performs a well-defined task. Okay, so rather than writing this code, I'm rewriting it in this particular manner. Okay, definition, we use a keyword def. I will come to the syntax and all. So we specify that we have a function called as sum, which takes two parameters I1 and I2. Okay, and we compute the sum as, initially we say that the result is 0, and we write a function called a we write a loop for whose range is in between I1 and I2 plus 1. Why? Because I want I2 also to be included in the sum. So the range is I1 comma I2 plus 1, and I take a placeholder I or whatever. You can take value, what you can give any name here. It need not necessarily be I also. So every time I fetch a value in this range and I keep on adding to the result. After the for loop is over, I return back the result. Okay. So this way I'm writing a generic module wherein depending on the values I set for I1 and I2, I can compute the sum of different ranges. If I1 and I2 is set to 1 and 11, uh, 1 and 10, it will compute the sum from 1 to 10. If the range is set from 20 to 37, it will compute the range. Okay. So I define the task once and reuse it multiple times. Okay. So these are called as function calls. So if I run this program, okay, I am sharing it. You guys also can run it. Copy paste this code. Function demo.py. Okay. Finished?
Yes, sir.
Okay. Yeah. So let us again go back to our analogy of the shop. Okay. So I have a particular billing system in my shop which takes care of billing. Okay. So what I will do is I will train one person as to how to perform this billing. So from here on, whenever I need to generate a bill, okay, or whenever the customer has finished choosing all their items, so he has to come to this person and get his billing done. So whenever I require the task of billing, I will call this employee only. Let's call this employee 1. I will always call upon employee 1 to do the billing. Okay. And that is better also. Like now, if I say, if I ask the employee 2 to do the billing, he has to learn that billing system, how billing is done, and then he will be able to generate the bill. Okay, so that will be cumbersome and sometimes it may lead to error also. Instead, I will train one person in billing and he will, so whenever I require billing, I will be calling upon the same person. So that way, the chances of getting the bill wrong is greatly reduced. Okay, and the task of the employees also is reduced. Okay, so this employee 1, he needs to worry about only doing the billing stuff. Okay, similarly I can assign some other functionality or some other task to employee 2. Okay, like for example arranging all the items in the shop. Okay, it is his job. So he will be always arranging the items. So what he will be doing, he will be checking all the rows. Wherever a particular item is empty, he will replace it with the appropriate item. Okay, something like that. So similarly, in programs, okay, the equivalent of employees are functions. So I write one particular function to carry out a well-defined task. Whenever I require that particular function to be done, okay, I will call upon the services of that particular function to get that task done. Okay, so here we have defined a function, and later if I want to find the sum of 1 to 10, I am not writing the code again, rather I am just simply calling the services. Okay, sum of 1 comma 10. So this highlighted part, this is called as the function definition. Okay, so if someone requests the services of this function sum, what is to be done? Okay, that is defined here. Okay, so here what is defined? The procedure to find out the sum in the range I1 to I2 is defined. Okay, so that's why we call this the function definition. And the point at where you make use of the services, make use of the services of the function, we call it, okay, not this hash, okay, function call. Okay, we call this as the function call to the function. Okay, so here in the print statement, when it encounters sum of 1 comma 10, okay, it now calls upon this function and passes these values 1 to 10. Okay, 1 will be stored into I1, 10 will be stored into I2. Okay, and appropriately it will compute the result. So it will compute the sum of the result, and we have a return statement here. It gives back, after this function was called, it gives back the result, and sum will be replaced with that. This call will be replaced with the return value. Whatever value you get, because it is in a print statement, it gets printed. Okay, 55 gets printed. Next time when I call sum of 20 comma 37, I1 will get a value of 20, I2 will get a value of 37. It will compute the sum. The sum is 513. That value is returned back here. So instead of this function call, we get the value 513 being printed. Okay, so let's look at uh, the structure of a function, the syntax of writing a function and all. Okay, so first, function definition. The general syntax is you have to use the keyword def. Okay, so this is a keyword which which is instructing that here is where I am going to start the definition of a new function. After def, you should choose the name of a function. Okay, so you should choose some name for your function so that anybody who wants to make use of this function knows how to call this particular function. He will call the function by its name. So how do we choose the name of a function name? Okay, function name should be a valid identifier. Okay, we already know as to how to choose identifiers. So function names can consist of only alphabets, digits. What else can be in a function name if it is the same as an identifier? Apart from alphabet and digit, what other characters can you use in variable names? Hello?
Yes, sir.
What
So
else
do
can
you
you use
mean
in
in
a function
the
name?
so do
Name
you
of a
mean in
variable,
the
like,
beginning
yeah, at the, anywhere for the matter. Beginning, we will discuss later.
underscore?
Underscore, right? Okay. So function names can consist of alphabets, digits, and underscore. Okay. However, at the beginning, you can make use of only what? At the beginning, what can you have?
Only alphabets.
Alphabets, or you can't have digits. Means what does it imply? You can have
Oh,
alphabets or an
underscore.
underscore also. Okay. So like how you name variables, you follow the same rules for naming your function also. Okay. Did you get this part? Hello?
Yes, sir.
Tanmay? Tanmay, is it clear?
Yes, sir.
Okay. So for example, here I have a function name Heron. Okay. You can choose any such name. Okay. As long as it is valid. Okay. It should consist of alphabets or digits or underscore, and it can have only alphabet or underscore at the beginning. Okay. So I can write like Heron underscore calc also. Okay. This is also a valid name. But however, I can't write Heron hash calc. Okay, this is a invalid function name because hash is not allowed as part of the identifier or a function name. Okay, after choosing the function name, then we need to specify the list of parameters for doing the computation. How many parameters do I require? Okay, what are the variables when I am doing the computation? What is the input parameters that I would require? That we specify here as a list of parameters. So each parameter should be separated by a comma. For example, in this case, let's say I want to write a function which finds the area of a triangle whose side lengths are given. Okay. So how many sides does a triangle have?
3.
3. Okay. So I need to give 3 parameters. Okay. So every time the formula that I use, the way that I compute the area of a triangle will be the same. What differs is only the side lengths A, B, and C. Okay, so these things that differ, we pass them as parameters because first time when I'm calculating, let's say for one triangle, it will have one set of values for ABC. If I want to calculate the area of another triangle, okay, then the values of A, B, and C would be different. However, the formula or the method for calculating the area of a triangle remains the same. Okay. So in this example, we are using the Heron's formula. We find out the semi-perimeter a plus b plus c by 2, and then use the formula area of triangle is equal to square root of s into s minus a into s minus b into s minus c. Okay. So if we use this formula, we will get the area of the triangle whose side lengths are a, b, and c. So this is how we write the function for parameters. After parameters, we have to use the colon symbol, and optionally you can write a documentation part. Okay, so this is a string. Okay, this is a triple quoted string. Do you remember this string? What kind of a string is this? What we mean when do we use a triple quoted string usually?
When we need to write more
Huh.
than two lines.
More than one line. Okay,
Sorry,
multi-line.
my
If you
bad.
have a multi-line string, if you have a multiple line string, we use this triple quotes. Okay, so this is optional. So when you write this method, if someone is going to use it later, you can provide him help or providing a description by using this documentation part. This is called as the documentation section or the doc string. Okay, so this is a special string, multi-line string. If we use it in the functions, we call it a doc string because it contains documentation, information about the function. So in this case, I have written the definition, the documentation as this function calculates the area of a triangle using the Heron's formula. Okay. However, as I said, this doc string is completely optional. Okay, got it? Next, you will write the calculation part. Okay, and observe all the instructions in the function that are part of the function should be written at a tab, like how we did in case of while and if. Same way, we have to use a indent here and write the instructions. Okay. Later, you can use if and while also within function names. We'll see those examples later. Okay. So here it's a simple computation of two steps. We compute the semi-perimeter and then we calculate the area. And after computing the result, okay, we are returning that result back. Okay, so this part is called as the function definition. If I just write a function definition, it is of no use unless I actually make use of it. So to actually use a function, I have to call the function. Like if you want to get billing done, what you are going to do, you are going to call upon employee one. Okay, similarly, if I want to calculate the area of a triangle, I should call the Heron function. Okay, so to call that, we use the function name. That's all. We don't write def before that. In a function call, you will write the name of the function and you will specify the actual values for these parameters. So in this case, it is going to calculate the area of a triangle whose side lengths are 3, 4 and 5. Okay, so this is called as the function call. This part is called as the function call. So 3 will be stored into which parameter in our function definition? 3 corresponds to which parameter here?
A.
A. Okay, so there will be a one-to-one correspondence. First parameter will be copied into the first parameter in the function definition. So 3 will be copied into A. B gets a value 4, C gets a value 5. Okay, after that, the return statement in the definition again is optional. It depends. Okay, whether your function after doing the computation wants to return the result or not return the result. Okay, we'll see that slightly later. So in this case, after computing the area, we are returning that result. So when the function call finishes execution, this function call will be replaced with the return value. Okay, whatever is in area will be replaced here, and later it can be assigned into a variable. Okay, I have created a variable try area. Try area is equal to Heron. Okay, so let's run this program. Copy. Okay, let me paste it into StreamYard. You can also copy it. Okay, I think write return area together. It went into a second statement. Just copy and write finish area. Let's copy here. Okay, so let me comment it out completely. Control V. Heron function. Try area is equal to Heron of 3, 4, 5. Okay, you can choose different values. Try area, print area of triangle is try area units.
Sir, you have to import math.
Yeah. Import math. Okay, do the import outside the function definition, not inside the function definition. Okay, area of triangle is 6 units. So now you modify the program such that instead of specifying fixed values like 3, 4, 5, ask the user to enter the values and then calculate the area of the triangle. Let's say those values are v1, v2, v3. Okay, so how do you read the input? Tell me, what should I write here? V1 is equal to
Eval input.
huh, eval no, not double quotes. Eval input. Okay, something like side 1. Okay, or enter side 1 maybe. Even better. Enter side 1. Control C. Side 2, we store it into V2. Side 3, V1, V2, V3. Okay. Now, how can I calculate the triangle area now? Hello?
Um, we should define
We should define what? We should define the function. Function is already defined. I have to only reuse.
so it'll be
Heron of. What should I give here?
v1 comma v2 comma v3.
V1 comma V2 comma V3. Okay. Then you can display. That we can use the same. So first one, you have fixed values, it computed because it doesn't require input. Second triangle, we have to give the input. Let's say 6, 8, 10. Okay, the area would be 24 units. Okay. So this is how we make use of functions. So whenever I want to reuse a particular set of instructions, I can code that as a function, and wherever I want to reuse it again, I just need to call it. Okay, so that's the idea of writing functions. And let us see the execution of them, like how they work. Okay, so this function, there is already a built-in function. Okay, but we for the sake of example, we are trying to write our own maths function. Okay, so or okay, I will choose a different name for it. MyMax. I will call this MyMax. Okay, just look at the code. You don't need to type this program. Look carefully. Okay, so given two parameters, num1 and num2, I have to return the largest of the two numbers. Okay, so a simple thing, if num1 is greater than num2, I store num1 as the result because num1 is greater. Otherwise, I return num2 as the greater value. and then we return it. Okay. Then we have written another function called as the main function. Okay, def main, and there in this function we have written I is equal to f j. Okay, just before doing this, let's do one more thing. I will come later. Control 1. I will remove that for the time being. Okay. Let's say that I don't have any other functions. Okay. I is equal to 5, j is equal to 2, k is equal to my max of I comma j. So the program will look at the definition first. Okay. So it knows that okay, function has been defined here. It comes to line number 11. It sets I to 5, j to 2. When there is a function, when it starts executing line number 13, okay, it sees that there is a function call. So whenever there is a function call, the control from line number 13 is passed to the body of the function, definition of the function. Okay, it comes to the function, and then takes these values I and j along, and stores them into num1 and num2 respectively, and then executes this body, returns the result. The largest of the two would be stored into k, and then it gets printed. So let's see how the execution works. So I will put a breakpoint here. Okay. Let's run the program in debug mode. We'll run one instruction at a time. Okay, it has come to line number 11 and stopped. I is equal to 5. I is equal to j. Sorry, j is equal to 2. Why is it not showing up in the bar? One minute. Maximum of 5 into is 5. I think I have to restart this. Just give me 2 minutes. Yeah. Okay. So after line number 11, variable I was created with a value 5. Next, we have the value j. Observe carefully here what happens in line number 13. Okay. So from line number 13, there is a transfer of control. What did you observe here? Hello? Hello?
Yes, sir.
Yes, sir.
What did you observe? What did you observe here? What happened? From line number 13, where did the control go? The blue arrow? Line number 2. Okay. Or wherever this function, so this is called the function call. MyMax was called here. The control was transferred to the MyMax function. Okay. And the parameters num1 and num2. What are the values in num1 and num2? See here, 5 and 2. The same values as I and j. Are you observe? Can you see the variable explorer here?
Yes,
sir.
sir.
Okay, so num1 and num2 now have copies of I and j, 5 and 2. Next, we execute the next statement. Okay, it checks whether num1 is greater than num2. Is 5 greater than 2? Yes, the condition is true. So result will be created now. Result is equal to num1. Okay, result will contain now 5, and we are returning the result. Okay, so when I execute this return statement, okay, it comes back to the point where it was called, substitutes that value instead of my max, and so what was the value of result in our function? Can you tell me, when the function was executing, what are the value of result? Num1 was 5, num2 was 2.
Result will be 5.
Result will be 5. Okay, that returned value 5 will replace this function call. Okay, and so now we will have 5. 5 will be stored into k. You can see k variable also having the value 5. Okay, after that you can run the next statement. The print statement is executed. The maximum between 5 and 2 is 5. Okay, so whenever there is a function call, the control is transferred from here to the body of the function that has been called, or the called function. Okay, so what I will do is I will just make slight modifications. Stop. Control 1. Okay, I will write another function called as main. From within main, I am going to call my max. Okay, and this main function also is called here. So let's run this in the debug mode. So always now it sees there is the definition of the my max. It goes forward, it sees the definition of main. Here the main function has been called. Okay, so from main it goes to the body of the main function, the definition of the main function. It is executing I is equal to 5, j is equal to 2, and when it comes to k, okay, there is a call to my max. So from my max it goes to sorry, from main function it goes to my max. Okay, it is executing the body of my max. It returns back to the main function. Okay, and stores that return value into k. Afterwards it will execute the next instruction in main. Oh no, I should not step. Okay, so what you should observe here is print is also a function, but it is a built-in function. Okay, that's why it went inside the print function and came back, and it prints the result. Maximum of 5 and 2 is 5. Okay, and the program terminates. So this is with regard to basic functions. In the next class, subsequent classes, we will see more examples and more variations of the functions. Okay, we'll stop it for today. I think we will next meet possibly on 17th or 19th. Okay, till then you will have a break. I will post a few more assignments and also all the programs that I have done probably by today night or tomorrow morning. So you can try out those exercises in your free time, and also go through again these program examples that we have done. Try to write these programs on your own. Okay, try practicing them and you will learn them better. Any queries you have for today?
No, sir.
No, sir.
Okay, yeah, okay then. So we will stop here. I will post you whether it is 17th or 19th depending on when I will be back. Okay, so till then, so you keep practicing your programs whenever you are free. Okay, okay then. So we'll stop here.
Thank you, sir.
Yeah, thank you. Bye.